Let's start with the objectives of this tutorial. Diffraction of light. We observe the diffracting behavior of light in daily life. Here, I will briefly explain few diffraction of light examples which are given below. Compact drive. Hologram. A beam of light enters a dimly lit room. Crepuscular rays. X-ray diffraction. Water passing from a small gap. Lunar/solar corona. Sound. Ring of light around the source. Signal propagation. Compact disc. On compact discs, the phenomena of diffraction is more susceptible. The compact disc's cover is shimmering and has a lot of holes. As light strikes the surface of a compact disc, a portion of it is diffracted, while the rest is reflected. Because of this, a rainbow-like pattern appears on the surface of a compact disc. Hologram. Light diffracts in different ways when it passes across the hologram, creating both physical and artificial pictures of the item utilized to reveal the film. The interference arrangement is the same as that produced by the object. Guiding your sight around the interference pattern, much like staring straight at the item, provides you with alternative viewpoints. As a consequence, the picture seems three-dimensional and mimics the item. It's a fantastic creation with a promising future forward of it. Diffraction is used to create a 3D perception of the picture in a hologram. Various copies of the picture are dispersed and arrive at the lens from various directions, resulting in an interference pattern. Using this configuration, the holographic layer is then left to drop, eventually creating a three-dimensional experience for us. A beam of light enters a dimly lit room. A unique phenomenon occurs as light penetrates a darkened place from a small aperture. The word diffraction is used to explain this phenomena. This occurs whenever the object's or aperture's size, in this case, the little hole's edge, is equivalent to the wavelength of the light ray. Diffraction is the intrusion of light into areas previously under shade. The light rays bent? Not literally, when they touch the surface of the narrow opening causes this diffraction. The brightness is subsequently dispersed into a center maximum and afterwards around center peaks that diminish in breadth and brightness as they radiate outward due to diffraction. Crepuscular rays. In atmospheric optics, crepuscular beams are solar beams that look to spread out of a solitary patch of sky. Such beams are pillars of sunlight wind split with darker cloud-shadowed areas that flow via openings in the cloud or among other structures. The term stems from the fact that they are most common during crepuscular hours, dawn and dusk, whenever the disparities among light and shadow are more pronounced. Everyone might have witnessed this magnificent sight at least once in their life. Crepuscular rays, often referred as heaven beams, are stunning-looking beams. The beams are diffracted and diverted as they try to reach the Earth, but are hindered by fog. Diffraction is the bending of a beam caused by the occurrence of an obstacle in its usual route. You may tell others why you think a vista is so beautiful. Again, you see one. X-ray diffraction. Because of their uniform spacing, the atoms of a crystal produce an interference pattern of the ray included in an entering wave of X-rays in X-ray diffraction. The microscopic faces of the crystalline operate on the X-rays in the same precise way as an uniformly controlled grating operates on a light beam. As a monochromatic X-ray source engages with a target surface, the dispersion of those X-rays through atoms inside the target surface is the dominating effect. The dispersed X-rays interact constructively and destructively in substances having uniform organization, i.e. crystalline. That's the diffraction mechanism. Bragg's law describes the diffraction of X-rays using crystals, theta. The accessible diffraction patterns are determined by the magnitude and shape of the material's unit cell. The type and configuration of particles in the lattice arrangement impact the intensity of diffracted waves. Most materials, on the other hand, are polycrystalline aggregates or powders, which are made up of numerous small crystallites in all conceivable configurations. Once an X-ray source is focused on dust with arbitrarily aligned crystallites, the ray will observe all potential interatomic surfaces. All conceivable diffraction maxima from the dust will be identified if the observation angle is consistently varied. Water passing from a small gap. Diffraction occurs when water passes out via a hole and is scattered out. The degree of diffraction increases as the wavelength of the wave increases. If the spacing width is roughly the equivalent to the wavelength, the most diffraction occurs. Whenever a lake's moving water comes into contact with a tiny slit, it is likely to interrupt its usual movement. The water wave curves on both sides of the slot. Such a curving of a water wave is another example of diffraction. Lunar/solar corona. The light that goes via the fog droplets is diffracted and diffused when the gap among the droplets is comparable to the wavelength of visible light. The illumination we observe originating from the moon on a cloudless sky, for instance, is coming directly from the moon. Conversely, if a small cloud covering is present between the viewer and the moon, the diffraction and dispersion of the moonlight results in an illumination that is brighter in comparison to the actual. The ring of light that encircles the sun or moon is known as the corona. The term corona refers to the brightness circle that develops around the sun or moon following sunlight or moonlight is diffracted by microscopic humidity or ice particles. The lunar corona is the moon's ring, whereas the solar corona is the sun's ring. Sound. We are capable to catch the voice if it is said out loud. Will we be capable to catch the voice if the person who is shouting stand behind a giant tree and yell with the same strength? Yeah, so why do the sound ISNT obstruct it if a massive tree is in the way? The reasoning for this is that sound passes and hits our ear via the diffraction phenomenon. Because the same process that enables rays to curve about barriers also allows them to expand out through tiny holes, one might think of diffraction as having a contradictory character. This diffraction property has a lot of repercussions. Apart from being capable to listen to the noise when standing beyond the room, this extending out of sound waves has implications for soundproofing a room. Since any holes enable noise from the outside to propagate out in the room, effective silencing necessitates a well-sealed space. It's amazing how much noise gets going via a small crack. Speaker system enclosures must be well sealed for identical reasons. Ring of light around the source. When we stare at some source of illumination surrounding us, we see that the sunlight ISNT transferred exactly in the straight path. Instead, a little portion of the illumination output is diffracted near the origin. Attributed to the prevalence of dirt and aerosol molecules around, light gets diffracted. Signal propagation. In protracted wireless data transmission, diffraction is critical. Line-of-sight dissemination over great distances is impossible because of the Earth's curving face and massive barriers. That is why, in order for a message to achieve its target, we need multi-level diffraction. The message continues to hit barriers while concurrently being boosted with the aid of boosters until it reaches its goal. Diffraction is in charge of how many phone calls you can take. Frequently asked question, FAQs. Q. What does diffraction imply, but why does it occur? Diffraction is the expansion of waves when they pass through an aperture or around barriers. It happens if the aperture or obstruction is the comparable magnitude as the entering beam's wavelength. A relatively small opening widths, the vast majority of the wave is obscured. Q. Can smaller wavelengths diffract faster than longer ones? Diffraction occurs at different angles based on the wavelength of light, with lower wavelengths diffracted at a steeper angle than the higher wavelength. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. scientific calculator and many more other tools.